Day one, and we will cover all the topics about a CCNA in a step by step. Okay. Currently, we are planning that we will meet for 3 days a week. Our timing will be like 8:30 Indian Standard Time, and in this session, we will talk about the new CCNA Enterprise Edition. Maybe I think it will be like 60 hours of training, and we will cover all the topics of the CCNA as per a blueprint from the Cisco website, right? So before I start my session, I want to introduce myself. Okay, so let's start with our mind map first. Yeah. So let me share my screen with you. Wait a minute. Yeah, I hope you are getting my screen right now. Okay. So this is the topic for the day. Okay, we are going to cover this four that I will go through. I will get it from the survey. Okay. So our today's first topic is a trainer introduction time, and when you finish this, you will get the certification signed with the Bill Gates. So I was quite excited when I started the training and all this, and but when I gave my first exam of the Microsoft, and I got failed result, because because actually the lack of the trainer, the training was I completed was not well trained. It was not from the well trained faculty, and because of this I'm not able to pass the exam. Okay, I'm not blaming anyone, but this was the scenario. Okay, and then I started preparing for myself, and I got the detail from the friends and all this, and then I'm able to pass all the 6 exams. Okay, and at that time I decided for the training, like by getting a training from the best faculties is really hard. Okay, and from last 17 years I was busy with my training institute. I train, I think, 5 to 7,000 people. And during this COVID, like in this 2 month of lockdown, I got time for myself, and then I decided that I want to give something back to community. Okay, and then we started for this type of the training, in which it will be like free training. Okay, uh, so my intention is very clear. I want you to be successful in after this training, and and I want to create a community which is having a full knowledge community with the full knowledge. Okay, they are able to get the job easily, they are able to pass the exam easily, they are able to crack the interview, because all this is a necessary components, right? Suppose if I got training, but if I'm not able to pass the certification, okay, my training, I will lose everything, because certification is required in this particular era. And same way, I got the training, I passed the exam, but somehow I'm not able to pass the interview. Okay, then it will be also problematic. Okay, so I believe in the complete training. Complete training means what? You will get everything. Like we will start with the training. We will include all the all the necessary questions that they are asking during the interview, during our training. Okay, and last 2 days will be for our examination. Okay, in these 2 days we will only prepare for the examination. And after giving, I think, after uh, 20 exams, online exam, I realized that passing the exam is really easy if you know some keywords about the question, right? So if you have a knowledge of this keyword, if you are able to catch up the keyword in the question, you are able to pass this easily. Okay, so I'm here to share all my knowledge in this next 60 hours. We will share everything. I will share everything with you. Okay, but now it is up to you. it is up to you how you can catch up all this. Okay, and I want to give you some little advice. Okay, if you want to catch this, if you want to really learn this, okay, I think you will get 100% organized training totally free first time on the net. Okay, I know there are many people having a video on a YouTube, on a Facebook, and everywhere. But the problem is, whenever you go for this type of the training, either it is not authenticated, either it is not live, or maybe it is unorganized. Now the problem is, if it is unorganized or it is an older one, you are not able to believe this training. Yeah, and if you are not able to believe this, and you are learning what you are not believing, okay, it is hard to digest. And that's why I organize this live training. Okay, whatever you are learning is the current as per day, okay, and as per the Cisco syllabus. And if you have any question, okay, you can ask me direct, you can message me, you can comment over here. So it will be like an interactive training. Okay, so if you have any question, you can just message me, and whenever we will meet next, I will solve all the problem of you. Okay, so it will be interactive training. But to get maximum out of this, I'm giving you one advice. Okay, if you are watching this from your mobile, or if you are watching this from your laptop, declutter yourself for this 1 hour. Okay, just stop Instagram or whatever the notification you are getting from the mobile phone. Just declutter from this. Okay, just stop this notification and hear me for the next hours. Okay, because focus is a requirement nowadays. Time is not money, actually. The money is a focus. Okay, if you learn anything with the focus, you are able to become a master of this. Okay, and this is my guarantee. Okay, just try it one time. Okay, give your time, give your focus to that particular training, and you are able to pass this exam for sure. And just passing the exam is not our target, right? Now you will pass the interview, or I think you will go for the better career for the CCNA. So this is an introduction for me. Okay, now let's talk about the blueprint. Okay, now we have a new syllabus for the CCNA. Okay, the older one is over. The older one is known as a CCNA RNS. Okay, and there are many variants for the CCNA. Like there was a CCNA Security, CCNA RNS, CCNA Data Center. So there was a many variant for the CCNA. Now Cisco stopped all this. Now we have one common certification for the for starting our journey as a network engineer, and this is a CCNA 200-301. Okay, now what is the main objective of the CCNA? And keep this in mind, the CCNA 200-301 is known as a CCNA enterprise. Okay, this is the only track from which you are able to start your journey. Okay, and they have a 6 topic that we need to cover during our training. Okay, so out of this 6 topic, the first topic is a network fundamental. Okay, it is a 20% of the entire syllabus. Okay, 20% topic is about the network fundamental. In the network fundamental, we will talk about what is router, what is switch, what is a access point, what is a wireless controller. Okay, so this is a very basic steps, and we will talk about this for the 20%. If you check out the blueprint, there is a 20% for the network fundamental. Then we will talk about the network access. It is also for a 20%. And then we will talk about the IP connectivity. Okay, so the routing will happen over here. Okay, we'll learn about the REAP, EIGRP, OSPF. Okay, every routing protocol. We will also talk about some live question. We will get this over the internet, and I will explain you which type of the question they are asking and how we can resonate this question with our training. Okay, so it is an important topic, and we can say that it is an older topic of routing and switching. Then we have IP services. Okay, security, this is one of the major topic. If you are interested for the CCNA Security, now CCNA Security is no more, but you can learn topic about the security over here the 50% of the syllabus covers the security fundamental. Okay, and if don't worry, if they are talking about the fundamental, okay, we will, I believe in the deep dive. Okay, so whenever we learn anything, we will be in the deep concept. Okay, so even though they, as per the blueprint, it is a security fundamental, but we will cover every topic. Okay, then the 10% is the automation and programmability. See, this is the super topic. Okay, many people, like previously I was a Cisco trainer, so many people calling me, and I got they're asking me the question like, sir, I think CCNA is like, CCNA is now not the skill which will give us a job. Okay, they have doubt about the CCNA certification. Okay, but my only one concern is that if you want to go for the Cisco track, like if you want to go for the CCNP, if you want to go for the CCI, the first step you should start with the CCNA. Okay, the first step is the CCNA. If you are CCNA, then you can able to get the training of the CCNP, and then you can able to become a CCI also. Okay, so the CCNA is the first topic. It is a enter gate to for the networking system. Okay, so if you want to go for the networking, you have to start your training with the CCNA. Okay, and now the most important point in the CCNA training is the automation. Okay, and automation means how we use our network with the programming. Okay, in this we will learn about the Python also. And if you don't have any knowledge about the Python, don't worry, we will talk about the Python programming and how it works, and then we will configure Cisco router using Python, right? So no need to worry about it. If you don't have any prerequisite knowledge, it is okay. We will cover everything. And for me, this is the one of the best point to learn. Like if you want to go for the programming of the networking, like the programming is, if you have a grip on the programming, this will be the most useful topic for you. It is a automation and programmability. Okay, so these are the topics that we will cover. If you want the detail about this topic, you can go to the Cisco CCNA, just Google Cisco CCNA, and from where you are able to get the PDF. It is called Exam Topics Blueprint, and it has all the topic that is available over here. Okay, now the third point, something about you. Okay, I want to know that what is your knowledge. Okay, so at the end of this video, I will share one Google form with you. Okay, I will share one Google form with you. Okay, just fill the form and submit the form. So I will get the detail about you, like which type of audience actually I'm going to train. Okay, I want to know this because as per your Google form detail, I'm able to design my training. Okay, so suppose if you people already having a knowledge of the basic like networking and everything, okay, I can skip this point and we can give much more time for the harder topic like security and automation. Okay, because our timing is limited. We are going for this training for 60 hours. So 60 hours is a final matter. Okay, so I will send you a form. Okay, after this training, you will get this form in this group, Target CCNA. Just fill the form and give it and submit it. Whenever you will submit, I will get all the data and I'm able to analyze the training. Okay, so right now I'm not going to waste any time for this. We will do it later after completing the today's training. Okay, now our fourth topic. This is the CCNA first day. Okay, from where we are able to start our training. If you check this in the network fundamental, okay, if you check into the blueprint, there is a first point is a 20% network fundamental. We are going to start our topic from over here, and here we have the first point. It is explain the role and the function of the network components. Okay, and here for today we will learn 2 points. Okay, the first point is routers, and the second point is L2 and L3 switches. Okay, so this is our topic for the day. Okay, and I'm going to cover this two topic with the combination. Like we will cover in a single explanation. We will cover all the topic like routers, L2 and L3 switches. Okay, to explain this, I am going to share you with sharing my whiteboard. So I'm going to minimize this and I'm going to cover my whiteboard. Okay, I'm going to start this process from very zero. Okay, it is like a first day. If you have a knowledge of this, it is very good. But if you don't have, just keep your eyes on the screen and listen it carefully. Okay, see, I have 4 computers in my network. Right, I have 4 computer in my network, and it is connected using the switch. So this is a switch, and these are the 4 computers. Okay, I'm just giving a name. Okay, so A, B, C, D. These are the 4 computers and connected using the switch. Okay, you know the basics. Like if you want to connect your computer with the switch, you must have the network interface card inside your computer. So all these computers having a NIC, then there will be the cable and the switch which is connected. All the computers are connected with this switch, right? Okay, now how these two computers communicate with each other. Like suppose if I want to send the data from A to C. Okay, this is my computer and I want to send the data to C. I want to send the data from A to C. Okay, so what is the process, how the communication happens? Okay, once we understand the communication, we are able to understand how the devices works. Okay, like what is the role of the switch? If it is a layer 3, what is the role of the layer 3 switch? What is the role of the router? Okay, so the first matter over here is how two computer communicate with each other if they are connected using the switch. Okay, now there are 2 requirements. The first is hardware requirement. Okay, to enable the communication between 2 computers, the hardware requirement is like you must have a switch, you must have a computers, you must have a cables. Okay, and you must have an NIC into the system. Okay, we will talk about the hardware requirement later because we have to learn about the cable type and all this. The second requirement is the software. It is a software. Okay, like suppose if I want to train you, the first requirement is how I can become live, how can I, which camera I can use. This is all the hardware requirement. The second requirement is the language. Okay, so I have to use the common language that must be understood by you and must be understood by me. Okay, so same like a language, if these two computer needs to communicate, we must have to use some type of protocol. And right now if we talk about the communication software, this protocol is TCP/IP. Okay, so if I want to enable the communication between 2 computers, this computer must have hardware. Okay, it is a connectivity point, and the second point is a software. And there is a one software, or we can say that a protocol, TCP/IP, is a commonly used for everywhere. Okay, now why TCP/IP? Actually there are many. Okay, so years ago, I'm talking about the years ago, when I think in 80s. Okay, uh, suppose if you have these 2 computers, for like these 2 computers are from Microsoft. Okay, the both computers are from Microsoft. Okay, at that time there was a protocol known as NAT BIOS extended user interface. So in 80s, 2 computer of Microsoft was communicated using the NetBUI protocol. Okay, if you have Apple machine, okay, they have a protocol like Apple Talk. Okay, and at that time there was one operating system, was a Novel. Okay, so if you have Novel, they have their own protocol, it is like IPX and SPX. Okay, so it was the scenario in 90s, or it is in 80s, in late 80s and early 90s. Okay, but after all, the TCP was introduced. Okay, TCP/IP. The first point about the TCP/IP is it was the internet protocol. Okay, and it is open source and supported by each and every operating system. So suppose if you want to use TCP/IP, you are able to use. Okay, it is a free for all. Okay, and the main advantage is it was a protocol of the internet. So Microsoft just drop out this NetView and then started to support TCP/IP. And then Apple also supported TCP/IP. Novel is it's very late, but they also support the TCP/IP. So what happened now? The TCP/IP is a common protocol for the network communication. It is a common protocol for the network as well as the internet. Okay, so the software that required is a TCP/IP. And now the biggest advantage is no matter which operating system you are having in this particular computer. Okay, so even if you have Microsoft, this is an Apple computer, this is a Linux. Okay, it doesn't matter. The matter is they must have a common protocol, and we have only one protocol that we are using right now. It is a TCP/IP. Okay, so the point is we have hardware, we have a TCP/IP protocol. So these two computers are able to communicate with each other. Okay, so we fulfill the requirement. Right now, how these two computers are able to communicate? So to understand this, oh wait a minute, I need to clear this out. Okay, we have to understand the basic requirement of the TCP/IP. The first requirement for the TCP/IP is the TCP/IP computer must have one unique address. Okay, it must have a unique address. Okay, and this address is known as IP address. Okay, the format of IP address, it is always 32-bit address. Okay, and they have separate octet, like this is the format. Yeah, it is a 4-byte address. Okay, and 32-bit, and each byte, like it is a 1 byte separated with dot, it is a 1 byte separated with the dot, it is a 1 byte separated with the dot, it is a 1 byte separated with the dot. Okay, so we can write like this. Okay, so this is the IP address that we need to assign. There are two ways to assign IP address. We can assign IP address statically, or we can assign the IP address using DHCP, but don't worry about it. We'll talk about all this. Okay, just for current training, just understand that there is a one address for every TCP/IP based computer, and the address in a format is like that, which I am writing right now. Okay, so don't worry about it. We will cover all the topics about the IP address as well. Okay, so the first requirement is, because we have TCP/IP protocol installed in our system. Okay, we have to assign IP address. There are two ways to assign IP address. One is a static, in which we can assign IP address manually, and the second way is we can use dynamic host configuration protocol, DHCP. Okay, but don't worry about the DHCP and all that. Okay, we will cover it. Now I have hardware, computers are connected. Second, I have a IP address, so all 4 computers connected using TCP/IP protocol, and all computer having a unique IP. Okay, the IP address must be unique. Keep this in mind. Now, what is the third requirement? The third requirement is each computer must have a MAC address. Okay, now what is this MAC address? See, if you buy any mobile phone, okay, it has a two numbers. One is a mobile number which you can add using a SIM card, and the second is a mobile number itself, like it has a mobile unique number of each and every mobile. This is known as IMEI number, right? This is IMEI number, which is built in with the mobile hardware chip. Same way, each computer having a NIC, and each computer's NIC having a one unique number, and this number is known as MAC address. Okay, so whenever you insert network interface card into the computer, and nowadays it is always built in with our computer, it has a unique MAC address. Okay, and if you want to check this unique MAC address of the system, you can give the command ipconfig/all, and you are able to check this out. Okay, if you want to check the MAC address of my system, okay, I can go to the command line and give the command ipconfig/all. Okay, I have many LAN card in the system, but I have to check to the Ethernet adapter. Yeah, this is Ether. Okay, it is for VMware. No, it's Ethernet adapter, and this is a MAC address of my computer. Okay, so this is actually a MAC address of my NIC, which is inbuilt in my computer. So each computer having a MAC address. And when we talk about the format of the MAC address, it is 48-bit. Okay, and it is in a hexadecimal. Okay, so just I'm writing like this: AAA, BBB, 1111. It is also unique. Okay, and it is always assigned by the NIC manufacturer. It can be anything. We don't need to worry about it, but we must have knowledge that each computer having this address, right? Okay. So now the first question is, what is the difference? Okay, what is the difference between IP address and MAC address? What is the difference between IP address and MAC address? I'm going to open the new tab of this. See, my question is, what is the difference between IP address, okay, and MAC address? Okay, the first difference is IP address is always 32-bit address. Okay, it is 48-bit. IP address is always in a decimal. Decimal means 0 to 9. Okay, and this MAC address is always in a hexadecimal format. Hexadecimal means it is 0 to 9 and A to F, right? And the third difference that you need to understand, okay, in the IP address there is a two format, like IP equal to network address plus host address. I will give you proper explanation about it. Don't worry, okay? And if you talk about the MAC address, it is only about the host address. Okay, I just yeah, I'm like underlying with the red line. Okay, I will explain you this about this later. Okay, it is not required right now, but just this is the three main difference that you need to understand right now. Okay, and the fourth difference is you can assign it. User assign this, and this is always built in, or it is a built in with the NIC. Okay, so we do not need to assign this. Okay, so these are four difference that you need to understand. Okay, now let's back to our system. Okay, so I have IP address, I have MAC address, I have 4 computers. Okay, now just want to check it out how these two computers able to communicate with each other. Okay, see, in our case, what I'm writing over here, suppose A, this is my PC, A wants to send data to D. Okay, A wants, let go for the C. Okay, A wants to send the data to C. A wants to send the data to C. Okay, so now how the process starts? Like how can A sends the data to C? In the normal circumstances, let's say that all the computers are Windows, like all the computers are Microsoft. Okay, so you can just like go to the run and type over here as slash, and you have to write the IP address like 192.168.0.3. It means you are saying to your PC that, hey, I want to access 192.168.0.3, or you can ping with the PC, like you can go to the command line, okay, and go to the CMD, and over here you can give like 192.168.0.3. It means you are giving the IP address, right? So you have to give the IP address of the system. It means it is a unique identity of the computer. So whichever the system you want to access, you have to give the IP address. Now there is another twist of the DNS. Okay, you can also give the name, but if you give the name, there is a system which is used to resolve the name to IP, and it is known as the DNS. We don't want to go inside this particular topic right now, because this is a little advanced topic than that we are learning right now. Okay, so I'm just making it simple. I have to give the IP address like 192.168.0.3. Okay, now what happened? So here what I'm writing again is A wants to send the data to C. A have IP address of C, right? A have IP address of C. Why? Because user assigned this. Like I wrote over here is 192.168.0.3, whatever the IP I assign you, because I want to access this, right? So user gave IP address to the A that I want to access 192.168.0.3. So this is 192.168.0.3. Now, this is the background process. Okay, what I am saying right now is a background process. Okay, A must have MAC address of C. Okay, see, IP address is assigned by IP address. We gave IP address to the C A, right? See, look A, this is 192.168.0.3. I want to access this. So IP address, okay, is A having this IP address, but to get the MAC address from the IP address is a responsibility of A. Okay, it is a background process, and that's why I'm using blue ink to write this. This is a background process, right? So A must have MAC address of C. To get the MAC address, A will use ARP broadcast. To get the MAC address, A will use ARP broadcast. Okay, to get the MAC address of C, A will use ARP broadcast. Now here, these are the two words is a new, like ARP and the broadcast. This is the two new words. Okay, the first word is a broadcast. Like, let's talk about the broadcast. Okay, there are three forms of communication. The one is unicast. Unicast means what? It is a one-to-one. Like A is sending the data to C. Okay, it is a one-to-one. Okay, one computer is sending the data to particular another computer. It is a one-to-one. It is called unicast communication. The second is known as a multicast. Multicast means what? One to group. Not all, but to the group. Okay, suppose if A is sending the data to B and C, it is based on the criteria. Okay, so it is not for all, but it is a one to group of people, or we can say that one to many. And the third one is broadcast. Broadcast means it is one to all. Okay, so whenever I do broadcast, it means I am sending a message to everyone. Okay, so suppose A is sending a broadcast, it means this message will be delivered to B, C, and D. Okay, so whenever I am saying ARP broadcast, it means whenever A will send this ARP broadcast, this message will be delivered to B, C, and D. Okay, so all these three computers together will get this message, right? Now the question is, what is ARP? Okay, what is ARP? The first thing that I want to clear is, I want to make it clear that TCP/IP, okay, TCP/IP is not the only protocol. Okay, this is a protocol suite. It means there are a 10 to 15 protocol working together, and it makes the TCP/IP suite. Okay, and they all are mapped with the OSI layer. We'll talk about the OSI layer. We will talk about the all the components of the TCP/IP, the sub protocol of the TCP/IP. Okay, but one of the TCP/IP protocol is ARP. Okay, and it is working with the data link. It is a layer 2. Okay, now the ARP is a responsible to get MAC address from IP address. Okay, so this is the responsibility of the ARP, which is a part of TCP/IP protocol suite. It means you do not need to find it or download it or install it. It is always there with the TCP/IP protocol. Okay, so whenever the requirement happen, okay, the TCP/IP stack remember this ARP, and it asks to the ARP, hey ARP, do your broadcast system and get me MAC address of this 192.168.0.3. Right? So the ARP will be used to get the MAC address, from the IP address. Okay, so what happened now? This computer wants this computer wants MAC address of 192.168.0.3, and it will use this ARP broadcast. Okay, so this broadcast will go to this like this. Okay, it will go to the cable and it will go to the switch. Now let's consider that it is a switch. It is a very basic. It don't know anything, and it is a broadcast itself. So what happens? The switch will send it to all the port like this, and like this. Okay, so all computer will get this message. Okay, so let me write it over here. Okay, so all computer will get this message. All hosts in the LAN will get this message. Yeah. Why? Because this is a broadcast. This is a broadcast means everyone will feel that yeah, it is for me. Okay. So now what happens? Suppose B will accept this. Okay, and then it will open this like, okay, this is the packet for me. Now let's open this. When the C will open this, there was the message like, if you are 192.168.0.3, give me your MAC address. So after opening the packet, B will realize that, okay, I am not 192.168.0.3, so I am not responsible to reply this. Okay, so it will not reply. Now same packet will go to this D. It is a broadcast, so all the computers will get this packet at a time. Now D will again realize the same. I am 192.168.0.4. This is for 0.3, so this is not for me. Okay, now C will get this, and the C will reply with the MAC address. Okay, he will reply that I am 192.168.0.3, and here is my MAC address. Okay, so this is the process from where A will get, it has IP address, it has already IP address, and it will get the MAC address of C. Okay, so now my computer like A having both IP address and MAC address of C, and now it is able to send the data to C. Okay, so this is the background process. Okay, and using this background process, A got the MAC address of C, and now A will send the data. Okay, it can be anything, like you are copying the movie, or you are copying the document file, or you are copying the JPG file, or anything. Okay, so this data will go through A to C, right? And whenever the data will go, like it is not the fixed amount of the data can travel through the cable. Okay, so the data will be divided into chunks, and then will be the segment, packet, and all this happen. And then this data, like the data will go through the chunks. The entire data cannot pass through the cable, right? So every chunks will be like this. It has a source IP. Okay, so suppose A is sending data to C. So what will be the source IP? It is a 192.168.0.1. Okay, destination IP will be like 192.168.0.3. Source MAC, okay, AAA, BBB 1111. Yeah, and the destination MAC, it will be AAAA, BBBB, and 3333. Okay, so it will be the data, all the data will be converted into the chunks. Then it will get the IP address, source IP, destination IP, source MAC, destination MAC, and it will travel through this device, and then the C will get this. Okay, now let's talk about the process, how these segments happen and all this. Okay, so to understand this, we have to understand a little bit about the OSI layer. Okay, so it is not the full explanation of the OSI layer. We will talk about the full explanation. I'm going to just giving you brief introduction so you can understand the switch, hub, and routers. Okay, so layer 2, layer 1, layer 3, and all this. So to understand this, we have a 7 layer of OSI. Yeah, what is this layer? What is this layer all about? The layers is a process how two computers communicate with each other. Okay, so this is a framework, and every vendors supporting this framework, following this framework to enable the communication between the two systems. Okay, so this is just a framework, like it is not the layer that you can see inside your NIC. Okay, this is the process which is divided into the 7 layers. The 7 layers are like application, presentation, session, transport, network, data link, and physical. Okay, if you, whenever you say, like in the interview, it is the most important point, people are keep asking about the layers, right? So whenever you say this, like whenever you write it or whenever someone asks you, always speak in a sequence. Okay, and remember it in the sequence. Okay, so how to remember this? To remember the sequence, you can remember is like all people seems to need data processing. Okay, if you want another one, I have one another also. Okay, this is like please do not touch sexy Pamela Anderson. Okay, so this is the way you can remember it. Okay, like you can remember from A to P, all people seems to need data processing. This is the one way. If you want to remember from physical to application, okay, please do not touch sexy Pamela Anderson. Okay, so this is the another way to remember this. Okay, now why I'm talking about this is, this is a layer 7. This is known as layer 7, and this is a layer 1. Okay, whenever you send the data, suppose if I'm sending the data, okay, the process will be like from application to physical. If I'm sending data to you, the data will pass through the application to physical, and if you are getting this data, the process will be like reverse process for you. It is from physical to application, right? It is from physical to application. Okay, not going to explain you everything, but the main important topic is whenever the data pass through the particular network layer, it will get source and destination IP address. It will get source and destination IP address, right? It is like, suppose it is a data, it will get source and destination IP address, and here it is called packet. Here it is called packet. When it passed through the data link layer, okay, it has a source and destination IP. Here it will get the source and destination MAC address, and it is called frame. Okay, so it is a responsibility of the network layer to add source and destination IP. It is a responsibility of the data link layer to add the source and destination MAC address. And now physical layer, actually it is not doing anything. It is responsible for deliver the data into the media. So suppose if you have cable, okay, cable connectivity, it will convert the data into the bits, and then it will put this data into the cable. If you have a wireless media, okay, it will convert the data into the radio frequency, and it will put it into the radio frequency, and then it will pass it through. Okay, so this is the physical layer. This is the responsibility of the physical layer. We also call it layer 1. Okay, and the physical layer only knows that how to put the data into the cable and how to get the data into the cable. Okay, physical layer don't know anything about the addressing and all this. Done. Now suppose you are the receiver, okay, and the first layer is a physical layer. So what happened when you receive this data? The physical layer will get this data from the cable, or if you have a radio frequency or all that, it will get the data. Okay, the physical layer, okay, it will not check anything like IP address, MAC address. It is not the responsibility of the physical layer. Okay, now what happened? The data link layer. Now this data link layer, like the data link layer of the source, is responsible for putting the MAC address and IP address, right? But the destination source address, MAC address, the destination data link layer is responsible to verify this. Okay, so this computer, the destination computers verifies that, okay, this is my MAC address. If it is yes, it will process the data at the upper layer or the network layer. But if it is not the MAC address of that particular destination, it will discard the data from that particular point. Okay, so it will verify this. If the MAC address is correct, everything is okay, okay, and the data will go at the next layer. It is a network layer. Now the network layer will check it out about the IP address. Okay, source network layer is responsible for adding the MAC address, source and destination MAC address, and this network layer is responsible for to identify this and verify it is my or not. Okay, so this is the responsibility of the different device, right? Now let's go to our main example. See, I have 4 computers connected using this device. Okay, years ago this was hub. Okay, years ago this was the hub. Okay, and nowadays we have switch. Okay, years ago it was hub, and nowadays we have switch. So what is the difference? Like, what is the difference? The main difference, the technical difference between hub and switch is it is a layer 1 device, and switch is a layer 2 device. Okay, now just remember the number, like just remember this. Hub is a layer 1 device, switch is a layer 2 device. Okay, and now let's resonate this with our layers model. Okay, we can say that physical is over here, okay, and hub is working over here. Hub is working with the physical layer. And if you talk about the switch is working with the data link layer, right? It is a switch. Okay, so we have physical layer and we have a data link layer. So physical layer is a hub, and over here we have a switch, right? It is working with the data link layer. So what is the difference between the hub and switch? The obvious matter is hub working with the physical layer, and physical layer also only knows that how to put the data into the cable and how to get the data into the cable. Hub don't know anything about the MAC address. Hub don't know anything about the IP address, nothing. Okay, so actually if you talk about the physical layer and hub, it will be like same. Hub don't know about physical address, hub don't know about the MAC address. Okay, hub only knows how to put the data into the cable, how to get the data into the cable. Okay, And if you talk about the switch is working with the data link layer. It is a layer 2 device, and the responsibility of the data link layer is add the MAC address and verifies the MAC address, right? The switch can verify the MAC address. Switch can verify the MAC address, but hub cannot verify the MAC address. Hub is a layer 2, switch is a layer, hub is a layer 1, switch is a layer 2. Okay, hub cannot verify anything, switch can verify the MAC address. This is the difference. Okay, now what happened? Okay, let's go with the same example. Let's go with the same example. Okay, but right now what I'm saying that I don't have this. Okay, I have hub. I'm having hub. Okay, hub is over. You will never get this device. Maybe maybe in an older network of a really old network, you maybe find this. Okay, in the scrapyard or something, you will be able to get this hub. I'm just explain you because you are able to understand the switch. Okay, you are able to understand the switch. Okay, so I'm going to cover all this from zero. Okay, suppose A wants to send the data to C. A have IP address of C. Yeah, it has. A must have MAC address of D. Okay, to get the MAC address, A will send ARP broadcast. So whenever A will send the broadcast, okay, suppose A is sending the broadcast, how will send it to everyone? Like, oh, I don't know anything. Okay, I will send it to anyone. All hosts in the LAN get this message because it is a broadcast. Okay, now A got the MAC address, A have IP address and MAC address both for the C. Okay, now whenever A will send this data, it will clearly define that, see, I want to send the data which is destination MAC is 333 and destination IP is 333 and destination MAC address is AABB333. Okay, send it to that particular computer. But here we have hub. Okay, and the problem with the hub is hub don't know anything. It is working with the data link layer. Okay, so what happened when the A will send it? Okay, this is a clear unicast packet. Okay, it has a particular destination IP and MAC, but this hub is like a dumb. They don't know anything. So what will happen? It will send it to this one, and this one. Okay, now whenever this B will get this, okay, it will check the MAC address and it will reject this. Okay, this is for ABBB33. I am 222. Don't waste my time. Okay, D will also reject that, B will also reject that, and A will get this. Okay, I am a 333. Welcome. This is my IP. Welcome, and it will get it this. So what happens? Suppose if you are sending 100 MB data. Okay, if you are sending 100 MB data, okay, it will divide into the chunks. Okay, and this hub will send all the chunks to this, and this. Okay, and B will reject every chunks, D will reject every chunks, and A will get all these chunks. Okay, yeah, this is for me, this is for me, this is for me. Okay, and because of this, the problem happens. What problem will happen? Suppose A is sending the data to C. A is sending the data to C. Now every packet is delivered to everyone. Okay, and now at the same time, suppose C wants to send the data to D. Okay, and B has to wait. Like B has to wait for the turn. Okay, and because of this, the hub network is known as single collision. It is called single collision. Okay, and number of, whenever you add the number of PC, okay, you will get your speed will be decreased in the hub environment. Okay, but now if you have switch, okay, it is a layer 2, it is a more intelligent device. Okay, so let's consider that we don't have hub right now. Okay, and we have a switch. Okay, so this device is a switch. Okay, and switch is a it is a layer 2. It has a table, okay, which is known as a CAM table, or we can say MAC address table. We'll talk about it in the switching subject. Okay, but it is a table. Okay, how to build this, it is a different matter, but for switch has a table. Okay, like 1111 is 22222, 33333, and D, it is a 44444. It is a table, right? And port number also, like one port, second port, third port. Now we have switch. It is an intelligent device. Okay, it has a list of this. It is built by switch itself. Okay, we'll talk about this, but let's consider the difference between hub and switch. So what happens? Suppose A is sending data to C. I'm going to repeat same thing. A wants to send the data to C. A have MAC address of C. A must have MAC address. To get the MAC address, A will send ARP broadcast. Now, whenever A will send the broadcast, this switch says, okay, this is a broadcast. Okay, if you want to send it to anyone, I don't have a problem. I will send it to the anyone. Yeah, I will send it to the anyone. Okay. Switch cannot break broadcast. And it was the exam question. Okay, years ago in the CCNA exam, this was the question. Why switch cannot break broadcast? And I will going to explain you when we learn about the switch. Okay, so don't worry about it. We will talk about all the switching process in the depth with the practical, right? Okay, so it is ARP broadcast, which never break the broadcast, and it's okay. Now all the computer in the LAN will get this broadcast. Okay, only C reply with the MAC address. Okay, now A have both IP and MAC address of C. Okay, it will check the source IP and it will add. Now A will send this packet again. A will send this packet again. A will send this packet again. Okay, it will check it out. Okay, it is a 333. See, switch cannot understand this portion. Okay, because it is a layer 2 device. Okay, it cannot concern about layer 3. So it will not understand this process. It will only understand this one. Like it will only read this. Okay, so destination MAC address is 333. Okay, so I need to send it to the 333 and it is connected with my port number 3. So what happens whenever this computer will send the data, switch will analyze this packet. Okay, it is a 333. It will check its scam table and then it will forward it to that particular C. So here is the big difference. Okay, in the hub, when A is sending data to C, all will get this. And because of this, hub is called a single collision. And in the switch environment, when A is sending data to C, okay, it will get only by C because the intelligence switch device. Okay, and this is a layer 2 switch. This is a layer 2 switch, right? Okay, now we have layer 3 switch. Now we have layer 3 switch. We will talk about all this. Okay, we'll talk about all this. Okay, in the tomorrow session, right? We will I schedule my session for the 3 days a week. Okay, we are going to meet Tuesday, Wednesday, and Thursday. Okay, second thing, if you want to do practical with me, you are able to do this. Okay, and for that you must have GNS. You must have GNS 3. Okay, right now for tomorrow we will talk about the theoretical topic. From day after tomorrow we'll start the practical. Okay, and for that we must have this GNS 3. So to install GNS with me, it will be live session. I will install GNS into the completely blank PC. Okay, and if you want to complete this step with me, okay, just download the GNS 3, latest version of GNS 3 from the GNS website. Okay, so you are able to install it with me, and then we will do practical and together. Okay, and I will send you workbook of all the practicals. Okay, so I will share workbook with you, but today I'm not able to share this Google form with you maybe. So we will do it tomorrow, and our time will be like same, 8:30 we will meet, and after 1 hour we will complete the session. Okay, I want your comment. Okay, so whenever I will finish this, you will get the recording of this. Like this video will be available in the Facebook in our group. Okay, and just give your comment. Okay, what you understand from today's lecture, or if you like which point you like most. Okay, and whatever you feel. Okay, you can comment. I'm going to read every comment of yours. Okay, and thank you for this 1 hour session. We will start from this point. For tomorrow it will be layer 3 switch and router. Okay, yeah, thank you.